Welcome back to my YouTube channel. This time we are going to go through Maxima and Minima. In our previous video we saw how we can get the stationary points, and getting the stationary points we got the maximum and the minimum. So we are going to see another application of differentiation involving getting the maximum and the minimum. We have an example here we are going to solve that requires differentiation. It says a rectangular piece of ground is to be fenced off with 100 meters of fencing wire, where one side of the area is bounded by a wall currently in place. What is the maximum? What is the maximum area that can be fenced? So our solution is here, right here. First and foremost, we can have a simple sketch. We have it drawn like that. This is our wall, but we are having fencing wire over 100 meters, so 100. So that means that our perimeter is given by 100 meters. If you add all of them together, then they said that one side is bounded by a wall, so there is already a wall in place. So it means that let me consider this to be the side with the wall. Now we know very well that if it is a rectangular piece of ground, it will have the length and it will have the width. So in this case, from the formula of perimeter is equal to twice into length plus width. Here we are going to go ahead and proceed and say, since one side of the length is there, so we shall have 2L plus 2W minus, we subtract off this one here because it is already available. This means that our perimeter now we shall have is going to be L plus 2W. But the size of the length we have is 100 meters, so we substitute 100 is equal to L plus 2W. After reaching here, we can make L or W the subject. That is, we can say let L is going to be 100 minus 2W when the 2W crosses equal signs. Then the question is asking us to find the maximum area. We know how to get the area. Follow the formula which says area is equal to length times width. Our area is equal to, the length we have is 100 minus 2W. Then we are multiplying it with the width, which is just W there. So area is equal to 100W minus 2W squared. When they talk of maximum area, those of you who watched the previous video, we said that for something to be maximum, we saw that the derivative, for example, for dx was 0. In this case, we are going to have, we state and say that for maximum or minimum whatsoever, the derivative of area with respect to width is going to be equal to 0. So we have to differentiate and say dW is equal to 100 minus 4W. Then we get this and equates to 0, so we have 0 is equal to 100 minus 4W. When you simplify, we shall come up with W being 100 divided by 4, which is just 25 meters. This is not the final answer. The answer, they want the maximum area. So maximum area is length times width. But in this case, I have the width, I don't have the length. So I have to come back and get the length. This is from L is equal to 100 minus 2W. My L is given by 100 minus 2 times 25, which is 50. 100 minus 50. Length is just 50 meters. Now I can substitute in the formula for maximum area. So for A max, it will be length, which is 50, times width, which is 25, And when I multiply that, I'll come up with the answer, which answer is this? Is it 1250 meters? So this is my maximum area.